Welcome back to the video lecture, students. So this is the continuation of lecture 1 in 4th unit, digital communication. So in the last class we have discussed about what is passband transmission, types of passband transmission, the techniques involved in digital modulation schemes. Then we discussed advantages of passband transmission, drawbacks. So in this class we are going to discuss about the representation of signals. So that is a geometric representation of modulated signals, or in other words we can tell the representation of orthogonality of modulated signals can be expressed. Signals transmitted over carrier will form either signal space or vector space. This is used to know about two important factors during the modulation. One is error probability and the next one is distance of individual messages. So here we are going to take n number of energy signals forming input signal set. The input is yi of t. The subset of vectors are y1 of t, y2 till ym of t. So these signals are represented in terms of n number of orthonormal basis functions. So what is orthonormal function? So in linear algebra, two vectors in an inner product space are now orthonormal if they are orthogonal unit vectors. So orthogonal unit vectors means they are perpendicular with each other. A set of vectors from an orthonormal set, if all vectors in the set are mutually orthogonal and all of unit length, that is all the set of vectors have the unit length, which means 1. An orthonormal set which forms a basis is called as orthonormal basis. So vectors in with the unit length 1, set of vectors are subset of vectors are orthogonal with each other. So that is nothing but orthonormal basis function. So here we have taken pi j of t and the subvectors are pi 1, pi 2 till pi n of t. So these subvectors are orthogonal with each other and the length is going to be, unit length is 1 based upon the energy signal. So the linear relationship between yi of t and pi j of t is yi of t is equal to yi1 pi 1 plus yi2 pi 2 of t till n and m. So yin of pi n of t. So y of t can be simplified as summation j is equal to 1 to n yij pi j of t. So yij is a coefficient of expansion. So yij is equivalent to 0 to t yi of t pi j of t into dt. So here the t is nothing but symbol duration. So pi 1 of t, pi 2 of t till pi n of t are orthonormal as we discussed earlier. Therefore we can relate the energy equation pi I of t into pi j of t with respect to the interval 0 to t, which leads to only two cases, two outcomes, 1 or 0. So the 1 will be equivalent when I and j both are same, and this will be equivalent to 0 when I not equivalent to j. I is equal to j. Let us consider this condition. So we are substituting the value 0 to t pi of t pi I of t. Both are going to be same because we have considered I and j are equal for the first condition. So this becomes 0 to t pi I square t. So once we simplify this equation, this gives 1. So that is the energy equivalent to 1. Similarly, I not equal to j, this will be equivalent to 0. So pi I of t into pi j of t, it is equivalent to 0 when energy is also 0. So this implies the basic functions of pi I of t till pi n are orthonormal. So we can conclude that y of t is equal to summation j is equal to 1 to n yij pi j of t. If they are orthonormal, the two possibilities are obtained. 1 for I is equal to j and 0 for I not equivalent to j. Thank you.